p plus t to the 1/3. But does that fit this form yet? What's not there? What do we have to have? We have to have 1, right? We have to have 1. Do we have a 1 right there? Do you see a 1 up there? So the big hint is they want you to do it in terms of t over p. We don't have a 1 right there. So what are we going to factor out of these two terms?
Do we divide everything by p?
No, we can't divide because we don't have anything to equal. We don't have anything to balance. So what can we factor? The only option here is to factor. What can we factor out of p and t? P. If you factor out p from this, what do you end up with? 1 plus what? T over p, correct? To the what power? Have we changed anything yet? Has anything changed about this expression? No. What do you do with powers here? What can you do with the power here? You can distribute it in, correct? So what do you end up with? P to the 1/3 times 1 plus t over p to the 1/3. What can we do with this now? Well, we treat p as a constant, everybody. We're not doing multivariable Taylor expansions yet, which we will get to eventually. But right now, p is a constant. So we can sit and just park that on the outside right there. What can we now do? Yeah, we could make it look prettier if we wanted to and let x equal what? T over p. So what do we have here? P to the 1/3 times 1 plus what? X to the 1/3. What can we now do? What can we now use? The binomial expansion. You need to remember what that binomial expansion is. 1 plus x to the p is equal to what? Can someone tell me what this is? You have to memorize this. This is not negotiable. Emily, what is it? Look at this and be like, I'm not quite sure. What's a great thing to do first, Sabrina? Yeah. Absolutely. I do that all the time. Really complicated expressions, when you actually write out the terms, can actually show you really cool things. So if you write out these, for following along with what you did in the video, I'm going to show all the lines. Okay, is that good? Plus what? 2 times x to the 2 minus 1 plus what? 3x to the, so what does this simplify to? 1 times x to the 0 plus 2x plus 3x what? Plus, do we get an idea now of what the pattern is? Integrated this? If we integrated, what does this become if we integrated this? Well, let's just do each term here. What does it become? It becomes x plus, right? You agree that if we integrated, that's what it becomes? That's not e to the x. What is that, though? That's a geometric series with a common ratio of what? So do you know what this sums to? What does that sum to?
1 minus x.
Careful, the first term is not 1.
Oh, sorry, x times.
The first term over 1 minus the ratio. What's the ratio? X. So we know if we integrated this Taylor polynomial, it sums to this, right? So we know the integral of this sums to this. So what do we need to do if we wanted to find out what the sum of the derivative is? We're right there. What do?
Just divide the n number.
That's what we did to get where we are. So to go back, so what did we do? This, we integrated to get to here, which got us to this, but we want to go back to the other side. So what are we going to take? So the sum here is going to be the derivative of x over what? 1 minus x. What do you need to use to do that derivative? Quotient rule. So that's going to be low times the derivative of high minus upper function, high d low minus low, sorry, low d high minus high d low. What's the derivative of the bottom? -1 all over what?
1 minus x.
So you simplify this a little bit, and what do you end up with? You end up with 1 minus x plus 1, right?
Plus x.
Plus x, not 1. Plus x all over.
1 minus 2x.
You don't do it out, and you can just leave it as 1 over. So what did we do there? We noticed that we were really close to something we could have. Remember those 3 things. You need to investigate substitution, differentiation, and integration. Balance them out carefully. And then it's plus what? Oh, I shouldn't skip terms, should I? X to the 3rd over what? Plus x to the over. Okay, so is that what Is that e to the x approximated to the 4th degree Taylor polynomial? Yes. What's the degree of this polynomial? 4. It is the 4th degree Taylor polynomial that approximates e to the x. Now, what did I erase there? I erased the equal signs. What am I turning it into? Little, almost, right. So here's the thing. When I plug in 2 into here, I get e squared. Exactly e squared. If I wanted an approximation of e squared, what would I do? I would plug 2 into this. It's going to be pretty close. Do that for me right now. On your calculator, everybody, do 2 into these right here. Tell me what happens. Tell me what happens. Go to 5 terms. As we add in more terms, this estimate should get closer to this. Everybody with me so far? So what is our error right now? If I wanted to calculate the error, what would I do? I'd do one thing. What operation would I do? I would subtract, right? I would subtract the absolute value of the difference of these two. So right now our error is 0.389. You with me so far? Okay. What's nice is we know it's going to go up a little bit. It stays positive. You do 2 to the 5th over 5 factorial. You keep going. It gets closer and closer. You with me so far? Okay, so let's go back to our statement right here. What we're really interested in between these numbers right here. If we were evaluating, if we picked any number x between these two, what's the maximum error we could have? That's what we're aiming to find out. Knowing the maximum error is really helpful in a lot of applications. So how are we going to do that? Look what it says here. N plus 1 factorial, x minus a. So can we start filling in some of those values? Yes. So what is our n value? E to the 1/2. We want it to be bigger than the biggest thing it could be, e to the 1/2. Now here's the thing. What's really nice is if we wanted to calculate this, we would then take m, and what do we let m equal? E to the half. So we know our biggest error bound is e to the over to the 5th right here. And you'll notice something. When you look up these questions in the answer key, they love to turn these into the next biggest integer. E squared, e to the 1/2, everybody, is the square root of e, which is 2.71 something, right? What's the best integer to replace this with? If you want it, can it be 1? No. Let's replace it with what? 2. The square root of e is definitely less than 2. So by replacing this, this is what we can do here. This seems arbitrary, but why does the book do things like this? Why is that 1/2 to the 5th? On the AP, the first thing you need to do is you need to remember, what was this? It was the error en in terms of x is going to be frozen. I'll get it on the, is equal to what? Parentheses what? The function value minus the Taylor approximation less than or equal to what? This is the key. You have to write this down. M over what? N plus 1 factorial, x minus a, absolute to the n plus 1. And then that's not all of it. You also have to write down what? Max of the absolute value of the nth plus 1 derivative of f has to be less than or equal to what? M on the interval. Okay, so you have to, if you don't write that down, it'll go real bad because many of you tried to jump to the last thing. The last question on this where it says compared to the actual is not the most important part. You need the logic. The logic is key here. When I took organic chemistry, it was my first example of the convergence of two things. You can overgeneralize difficulty of academic classes by saying, what does that mean on this? N is equal to what? 3. So what are we looking at here? Less than or equal to, I'll draw a line here, m over 4 factorial. And what's the a value equal to? 0. It says centered around 0. X to the what power? 4. But we need to find, remember that was the first stage. What did I say the second stage is? M, finding m. You have to write this down. The max of the nth plus 1 derivative, so that's the 4th derivative, is less than or equal to n on the interval. Well, some of you did this out. What is the 4th derivative? I think all of you got it. What's the 4th derivative? Cosine of x less than or equal to m on the interval. What do they not give you on this?
The domain of interval.
They don't give you an interval, right? It was a purposeful choice on their part to make you think about this. You're looking for the maximum value this can take on the interval, right? Well, here's the thing. If they don't give you an interval, you just have to think, what's the maximum value you can take anywhere What's the maximum value of cosine anywhere?
1.
1. So what are we going to set m equal to? 1. So when we do this out, we end up with this. 1 over 4 factorial x to the 4. Using this, it wanted you to figure out what the maximum error is of this, right? What value do you have to plug in? Negative 0.3. So what do you plug in down here? So this was our ENX right here, equals this. So they want the error, and n was equal to, and this was our fourth, right? Our third right there. So the error, 3, evaluated at what? Negative 0.3 is equal to negative 1 over, what is 4 factorial? 24 times what? 0.3 to the 4th power. This right here is the maximum error of the Taylor polynomial going to what? The third degree Taylor polynomial of cosine. Right there, that's what it would be. If you do that out on your calculator, you end up with 0.000338 right there. That's how good our estimate would be if we had the 3rd degree Taylor polynomial approximation of cosine. How do you compare this to the actual value? How do you compare it? Well, you do it on your calculator. You do cosine of negative 0.3, and you compare that to what some people were doing right off the bat. Some people were plugging in negative 0.3 into the 3rd degree Taylor polynomial. You do that at the end. This right here is the super important part. This. Getting to this. That's the key. Once you get to this, you'll be able to answer the AP questions, because they're going to ask, okay, so it's 3 over 10. 10 to the 4th is 10,000, right? You're going to have to show that this is like greater than some fraction. And it'll just pop out if you've sanded it nicely. If they had given you an interval, is that another step you might have to deal with? Could it be really crazy on the interval? It could be. Okay, before I